So Dick, over to you. Thanks very much.
Thanks very much. So I used to be a computer scientist, and now I've fallen in among designers. And that means that what I tend to do a lot more of now is talk about values and how we understand the ways that people value technology differently and the different things that people do value in these things. And one of the things about the blockchain is it's complicated. It means a lot of different things to a lot of different people. And so it takes a bit of unpicking to figure out what's important in different contexts. So I'm going to start in the pub, because that's always a good place to start. This is the Haymakers in Cambridge, and a while ago they started allowing people to buy beer with bitcoins. So this is the very first till receipt that they had, where someone actually did a bitcoin transaction and got a pint of beer in response. And this is one of the views that people have of it. It's a way that you can pay for things. It's a different kind of currency. You'll hear people say it's a ledger. Currency kind of works sometimes by being a method of accounting of who owes what. Ledgers used to be books, now they're decentralized. You'll hear a lot of people talk about it being anonymous. And yet you can look at companies like Elliptic who are going, and because it preserves every single transaction that ever happened on it, you can start unpicking who did what and when, and you can start actually re-identifying the people that have carried out transactions on the system. So it's a way to spend money, it's a way to keep track of accounts, it's a way to have a whole history of a million different things that happened. It's also a way to write graffiti, because alongside the financial transactions, you can store arbitrary data. So people are using it as a publishing platform. This is TextBlock, which is an RFC for how you do permanent publishing using blockchains and some other kind of indexing so you can find it again. So it gives you a way to write things that then persist forever in some sense, or at least as long as people keep running these things. So it gives us this way of looking at data where it goes out and it can then never change. So you can start thinking about provenance, and you can start understanding where data has come from and what's happened to it in the future. It's also a wonderful way to generate entropy in the form of heat. This is Genesis mining. This is one of their Bitcoin mining rigs. It's now not cost effective to be a Bitcoin miner unless you live somewhere with cheap electricity and you can get cutting edge circuit boards. Otherwise, you pay more for the electricity than you get paid back in Bitcoins. And all of these machines burning vast amounts of power. I think the Bitcoin network is about 500 megawatts at the moment, which is fairly substantial, and it's doing all of that to run 7 transactions per second, which is nothing. If you compare that to Visa, they're doing something like 100,000, I think. So there's several orders of magnitude in efficiency. All of these computers are doing useless problem solving. They're trying to find a hash with a certain structure, and the more computers that get added to the network, the harder they make that difficulty. So they make sure that even as we add more and more machines and we burn more and more energy, it still takes 10 minutes to find the number that makes each block work. And there's nothing magic or special about those numbers, except we've said they're important to Bitcoin. So it's a great way to generate waste heat. And we see some people rethinking around that. This is Joseph Lindley's crypto heater that was at Creativity and Cognition last year, where he said, right, well, if we're accidentally generating waste heat with all this computation, let's take the Bitcoin mining rig and attach it to a radiator, and at least it can keep my house warm. So that's an example of rethinking some of the values around these systems. And part of that is going, which bits of this are important to us? If you say, I'm not too worried about complete decentralization, I'm happy to have one trusted party in there somewhere. You can talk about centrally banked cryptocurrencies. This is a paper out of UCL, George Danzis and Sarah Michael-John. And they can create a network that is orders of magnitude more efficient than the Bitcoin network, because they're happy to have one central point in there that verifies things. So it means if you're thinking about doing stuff on the blockchain, you have to figure out what's important. This is from a page.
Sorry, could you define for a layperson what the blockchain is?
Right, I haven't been doing this in this talk. I could do an intro.
Or does everyone know? Am I just...
And I kind of assumed that other people would have
never
covered it.
assume. That's the thing, it's really difficult to know how...
If everyone else knows, I'll Wikipedia it, but I struggled in the last talk not knowing what the blockchain was.
If I can have 5 more minutes, I'll do a 5-minute intro
Go
to the
for it,
blockchain.
absolutely.
But don't...
Yeah, like I said, it's difficult to know, because sometimes, you know, when you get technical, half the room just lights up, and then the other half say, oh God. And so knowing kind of where to pitch, it's always a little bit tricky. So, yeah, I think this could be quite handy. And also, you know, why it's relevant to the Internet of Things.
Yeah.
Right?
So, Bitcoin is a ledger. It's a way to record transactions and say someone has transferred this value to someone else in some way. Just like the book that we showed, it records lines of money goes from this place to that place. Ledgers are easy if you have one person who sits there with the ledger and writes down everything that happens, and they're trusted. If we wanted to do one between all the people in the room and no one trusted anyone else, it would be really hard. So that's a lot of the problem that they're solving. So at root, it's a way to say, Alice has 200 bitcoins, she sends 50 to Bob, now Alice has 150 and Bob has 50, and now Bob sends some to Charlie. There's cryptography, so we always do Alice, Bob and Charlie.
Sorry, Dave, just to jump in. But the fundamental problem, right, and what this is trying to solve, is that, like I was complaining about the internet per se being too centralized, the entire global banking and finance system is too centralized. So there's always this kind of blob in the middle between two end users called a central bank or a clearing bank, and it's very clunky, it's very inefficient and flipping expensive. When you want to actually shunt money from one person's bank account to the other, particularly if it's transcending national boundaries, you can end up paying 10% of the overall, you know, amount of money or more, I'm not quite sure, you're trying to, which is crazy, and it can take up to a week for a check to clear. Bitcoin solves that by making it completely decentralized, so it goes straight from one person to the other, no central government, no central banking system involved. They are completely disintermediated. That means that the cost of a per transaction is almost zero. It almost is instantaneous, in theory.
And that one as well.
Exactly, but that's what, you know, that is the objective, that's the problem they're trying to solve, just completely rethinking the entire concept of global currency, how it works. And then with regards to the internet, instead of currency and money, you're talking about data and transactions. So money transactions and things communicating and contracts, they're no different, they work in exactly the same way, right? Okay.
So, this is what we're trying to do. We're trying to transfer money. One of the problems you might have is overspending. So if Alice tries to spend the same money twice, we don't know what's happened in this situation because the money, well, there isn't that money to spend. You might get blacklisting. So when Visa decides that they're not going to allow certain people to have money, Alice tries to send money to Bob, and the bank says, no, you're not allowed to do that. People might try and alter the past. So Alice spends 50 bitcoins to Bob, and then later on she goes, actually, that was only 5. Can I keep 195 instead of 150? So these are the kinds of attacks that people would do on financial systems. So when you want a decentralized ledger, you want it to be append only. So you can only add transactions, you can't change what's happened. You want to make sure it all adds up. So any coins in it can only be spent once. You want to make sure there's no trusted party who could blacklist addresses, demand fees, go offline, be a single point of failure, and you want it to be resistant to hacking. That's a quick sense of the design principles for a currency. And the blockchain is the way that Bitcoin does that. You'll find there are other blockchains out there, and it's a way to group up transactions into blocks to say, this coin was sent to this person who sends it here, it goes into someone's wallet, and then gets transferred to someone else. The thing that makes it a chain is that each of these blocks has a whole bunch of data in and a hash of the data. So that's the thing that says if you change anything in here, the number changes. Let's get the transactions. And each block has a hash of the previous one. So you have all of this data in here. This block says, right, I've got the new data, but I've also got a number that perfectly identifies the data in the previous block. And you keep building those on top of each other as a chain. And by doing that, it means that no one can go back and say, I didn't say that then, I said something else. Because you've got all of these blocks that have come afterwards that are built on top of that data, so nothing previous can be changed without changing all of the blocks in front of it. And that's a big part of what gives Bitcoin its security. So it's making a hash of the previous data, and then each time around you collect up a bunch of new transactions, you put them into a block, you add in the hash of the previous one, you do this magic of finding a special number that gives you a hash of your block with a certain structure that you have to do at random, and that's the proof of work that we saw happening. And you just keep adding these in, and that's it. That's the blockchain.
It's kind of, I mean, I suppose it's kind of like a sequence of truth. And once that agreement, that transaction has been complete between two machines or two humans, the blockchain seals it. And it's completely uncrackable in theory and immutable. So it's a little bit like a friend of yours and you kind of, okay, 50 quid, you owe me 50 quid if I get the round of beers, right? And you promise to pay me next week, okay? Now, what's to say next week, you go, you renege on the deal and you say, I never said that, I never owed you 50 quid. Even if you write an IOU, then what's to say that you either dispose of the IOU or actually meddle with it in some way and go, no, it's never 50 quid, look, it's 30 quid. I can't read the writing. This ensures that once that transaction, you've agreed to pay 50 quid, here are the terms, it's locked into the blockchain for all to see, so it can never ever be amended, changed in any way, shape or form. So in theory, it eradicates any possibility to change the truth or adapt the future, the past in any way to prevent future fraud. And that is what makes, again, this game changing, because it could theoretically eradicate fraud. And it's not just financial fraud, it's records. So it could do away with any kind of document fraud like passports, identity, and I think a lot of governments are transitioning into it. I think I'm done now. So, sorry, Dave, you're just getting going, right? There's more to come, isn't there?
Yeah, there's lots more.
So, just go for it. Quick question, then poor Dave needs to get his sort of rhythm back, and then we'll do kind of serious Q&A as a panel at the end if that works. So, go for it real quick.
So, I was just wondering about the example that you mentioned now. So, I owe you £50, someone might want to change it to £30 of it. That information is stored in the blockchain and you can't change it, which makes it secure against fraud. But where is that information actually stored?
It's a distributed system broken into nodes. Exactly. And that's
Yes.
the beauty of it. There's no central server to hack.
It's a whole network of machines. Anyone can join in and become a Bitcoin node. And then you start seeing all of the blocks that everyone tries to add to the chain. And part of what Bitcoin does is make sure that everyone has consensus about what the correct chain is. And part of that is one of the nodes will gather up some transactions, do this hashing thing, and then they send it out to all of the other nodes in the network. So anyone can have a list of all those transactions.
But therein lies the limitation,
if
right?
you want to, you can go and download it now. It's about 60 gigabytes, if I remember right. And you can then join in and start seeing all the transactions as they come through.
So it's turning into a bit of a double act, and I will shut my face in a moment, but just this is part of the limitation that every person who's participating in this distributed consensus-based banking system, if you like, gets a record of the ledger, anyone can actually see every single transaction because it's immediately, in theory, replicated on the hard drives of every single computer or node that's participating. And in order to give a little bit of your processing power, or quite a lot in some cases, to the cause, you are rewarded, because it costs you energy and money to host a Bitcoin node, you are given Bitcoins in return in payment. Do you understand? It's your incentive to keep a computer or a massive server farm of computers connected at all times, enabling these transactions to take place and storing a complete copy of the entire global ledger. And the problem is that every person who uses it, this ledger is getting bigger and bigger and bigger, and it's being replicated on every single node, every single computer, every single server. And so people are starting to run out of processing power and storage space, and this thing is too bloated, and that's why the whole system's starting to grind to a halt, because they're trying to replicate the truth, the ledger, across a global, decentralized supercomputer, essentially, made up of all these little nodes hosting this data and replicating it. And it's not really scalable because it's becoming too big and clunky. And that's why we've actually got to start rethinking the blockchain as a concept and look at other alternatives.
If you want, I can arrange to come back at some time and do a slightly more spaced out blockchain intro, because it's kind of hard to get it in these little sound bites. But one of the things I was getting to is it's really hard work to do this stuff. It takes a lot of energy and resources. So you have to figure out if it's worth it for a particular project. These are kind of all the things you should need if you think you want a blockchain. So in absence of trust, you want to have multiple people writing to your database. You want to have disintermediation. You want to have a choice of people who are checking that things are okay. You want to have interaction between the transactions. And if you don't have all of these, then the chances are you're probably better off using a relational database or an NoSQL database, or one of the more traditional tried and true ways of managing large amounts of data. So there's certain properties that are really important for blockchains that you often don't need in other places. Does anyone know what this is?
A cowrie shell or something?
Pretty close, yeah, same idea.
It's a coin.
It's a coin. This is a ray coin used on the Yap Islands in the Pacific. They're money. They're big. They're like this big. So when you have money that's that big, it doesn't make sense to actually carry it around and go down to the shops and then get your change, which is slightly smaller. So they don't actually move the stones. They have an oral history about who owns particular stones. They still use them for transactions, but they never have to actually move them around.
They did actually do it once, actually. Well, there was a reported case where someone was transporting stolen coins on a boat, and the boat sank, and something like his grandson tried to raise the coin afterwards because it was so valuable, but it was underwater, it was very difficult to do.
Yeah, so there's this story here from the island of Stone Money about a group who went out to mine a coin, and the boat crashed on the way back. No one's ever seen it, but they came back with this story of how big and wonderful it was. And that's enough that everyone believes it, and they agree that it's money, even though it's on the bottom of the sea, and no one's seen it. I wish that worked there in the pub. So there's this way that people construct value and exchange it, where the actual medium of exchange can be a bit abstract and elusive. And to some extent, that's what's happening on the blockchain. We're agreeing that these cryptographic objects have value in some way, even though we often don't quite understand what they are. So as a bunch of designers, one of the ways we do things is trying to help people think through what's going on. So this is a workshop that we do called Block Exchange, which is about making a Lego version of the blockchain. It goes in a few stages. It's about exploring the value of money in a kind of workshoppy context. And we start people with physical cards for resources that they want, that may or may not have value to them, and a whole bunch of Lego blocks. And they go through this exercise where if you want to swap an object, if you want to swap a card with someone, you write that transaction down, with your particular stickers on the Lego block, and you put it on this piece of Lego. And everyone does that. While they're doing that, there's another bunch of people with a computer trying to solve countdown puzzles. And when they've solved their countdown puzzle, they go, right, we've got a block now. And they come and put, I should have a picture of that. They come and put another of these green flat layers on top, and that seals the block. It says that no one can go back and unpick any of those transactions that have happened. And that keeps going round and round because it's a physical analog of the way that the blockchain works. And it starts out that people trade cards with equal value. I'll swap you 3 sheep for 3 wood. If anyone's played Settlers of Catan, that will sound a bit familiar. And then we start introducing fluctuations in the value. So now wood is worth 8 blocks, and this is worth 3 blocks, and things like that. But then the actually interesting bit is when we say, right, now trade anything you can think of. Because it's trying to decouple a sense of value from the cards that people have and think about what they actually want to do. And people come out with all sorts of stuff. They're trading their cat, they're trading a good Spanish joke. I would definitely play 2 Lego blocks for a good night's sleep. And some of this depends where you do it. This was with a bunch of designers at a design conference, and they instantly went from pens, nice physical objects, to a kiss, or a tweet, or they'll solve problems for you, or sing a song with your name. So this gives people a way to kind of think through value around things they might change using these mediums of exchange. This was a workshop where we also wanted to do some prototyping. This is kind of in the spirit of prototyping, so provocative prototypes. We go in there with unfinished software that does something, and we see what people do with it and what they want to make of it. In this case, we called it Geocoin, because it's about what happens when Bitcoin meets space and geography. Because there's all sorts of ways that geography and value are interconnected. There's certain places where just being in that place costs you money. That's Glastonbury. There's certain places where being in that place means you're not allowed to use money. That's Burning Man in the Nevada desert. So there's this relationship between value and space in that sense. Then this is the Bristol pound. This is a local currency. You can only really spend it in Bristol. It's pegged to the pound, but it's a way to ensure that transactions happen within the city, and people prefer using local suppliers. And that means that the money goes around the community rather than being siphoned out to larger corporations elsewhere. So it's an experiment in how we can change the way that people think about where the value of money exists. And so we start people with a map. This is a mobile app on the phone, and there's a few points that we put down. So you can have red zones where being there takes money away, green zones where being there you gradually get given money, and black zones where if you wander past them you pick up a chunk of money, like dots in Pac-Man, something like that. And then that gives us a space to think through what are the values around it, what might be behind these things. So it might be that there's a way to be donating when you hang out at the hospital. Just by being in that space you're transferring money to them. It might be that there's a toll bridge, so it costs you to go across it. Maybe the city wants to promote healthy lifestyles, so they say if you're hanging out in the park, we're going to incentivise that financially. Or it might be that's Albert Heijn in the middle, doing an in-store promotion. So they're using geolocated currency as a way to bring people into their shops. And then everyone runs out and they use the apps and they go and desperately try and pick up money before all the other people do. We start doing this with a database and then gradually move to using Electrum wallets that actually communicate with the blockchain and exchange real money. At which point, a couple of things became clear. One is, the way the blockchain works, it's at least 10 minutes before your transaction shows up. So that means as you go around and your app says you've picked up these bits of money, you can't actually believe it until that's actually showed up on the blockchain and been confirmed. So we end up with confirmed and unconfirmed balances. And that's about the way that Bitcoin works. It's about the affordances of that platform. The other thing we found out pretty quickly is that if you're doing little micro-transactions, as we were, shifting 10 euro cents around here and there, the cost of transactions ends up much higher than the amount of money you're exchanging. We were using Electrum wallets, and there you pay a transaction fee. You can pay nothing and it'll happen eventually, but the more you pay, the faster your transactions happen. So to make things happen at a reasonable rate, we were burning through money just shifting it around between our wallets. So some of the things about Bitcoin being completely frictionless change when you start working at different scales. One of the things we did was get the people to make videos of what they did. Anyone up for a 2-minute video?
Blockchain City presents Handfaster. Our relationships and activities have always been managed and governed by a set of rules, norms, agreements and contracts. And these have traditionally been created, approved and enforced by third parties, governments, legal bodies, religious bodies or company bosses. What if we could set and formalise our own agreements and commitments for a certain place and time, to enable a hyper-local economic zone with its own set of specific rules that are made by us, for us to use collectively as a group? Take, for example, marriage. Marriage is a contract or agreement between two people that has existed for thousands of years. Not all marriages are for life, though. In fact, most aren't. Many cultures have fixed short-term marriage arrangements. The Shia Nikah al-Muta or the Celtic handfasting in pagan rituals make marriages to last 3 days, 3 years. It's entirely up to them. So what if you wanted all the practical aspects of a legal marriage, companionship, commitment, financial security, without going through all the tedious and expensive legal procedures? Short romantic holidays. What better way to initiate a love contract for a week? Seal it in the blockchain, pull together your cash, and witness it with a selfie. You can't spend any money unless you are together. And you'll get special discounts and bonuses for getting the Amsterdam mini marriage. Thus making commitments wherever you are. Updating one of the oldest contracts into mobile, temporary, digital smart contracts. Handfaster allows users to create temporary economic zones with shared accounts that can only be spent when both people are in the same place. It turns the financial commitment and security of marriage into short-term solutions for shared banking and spending.
These people jump straight from the idea of you have money that works in certain places to, well, can we use that to make money that you can only spend when you're physically with another person? So it's allowed them to rethink the way that value and money works and comes together, and do something a bit weird and wacky and transgressive and make a nice video about it, so that we can start having these discussions about what's important about marriage. I'm going to skip the next one because I think I'm low on time. This was out on the pavilion in George Street over the festival. We turned it into a physical place where you can go and you can do a Bitcoin marriage. And it'll print you out a nice little marriage certificate. You can decide how many people you want to get married with. It doesn't distinguish. So as many people as want to can go there, all get married together, and then that gives them a pooled account that they can only spend when they're physically co-located. I'm going to go through one more project that was out in our pavilion as well. This is the Barista, which we think might be the world's first fully Bitcoin-powered coffee machine. So you go there, and you can use Bitcoins to buy your coffee. That's all fine, that's well and good, been done a million times. The place it goes is it will try and negotiate with people. It'll give you a free coffee in return for emptying out the ground floor. So it's become needy. It's trying to find ways to prolong its own life and its own existence, and it will do that by offering what it has to offer, which in this case is coffee. It also knows about where the coffee comes from, and you can talk about the supply of future coffee with it. It'll tell you about the different countries it could come from, and their political stability and their infrastructure and things like that. And it'll offer you a choice. Do you want to go for the best price, or do you want to go for the one that has the best social responsibility or the lowest environmental impact? So because this thing is smart, and because it has access to cryptocurrency, it can go out and it can buy its own coffee through an interaction with the people around it. So it's a thing that starts manipulating its own resources to keep it going, and negotiates with the people around it. So I've been talking a long time, I think. But I just want to come back to this sense of reconfiguration. One of the things that these technologies really do for us is it's not so much about the technology, it's about the new technology giving us a way to reconfigure our sense of values, the ways that we work. So when the web first started out, it was radically decentralized, and it was this incredible idea that anyone can connect and do things. And over time, that sort of ossified into a much more feudal, siloed, corporatized structure. So one of the promises of blockchain, cryptocurrencies, all of these technologies is that it gives us just this moment to go, what kind of world do we want to live in? And it gives us the tools to do something in a slightly new way. And it's doing those things in a new way that allows us to go, what are the things that we want to do? Do we want to be programmed by the infrastructure around us, or do we want to configure the infrastructure and make it react to what we want? I think we can skip that. So yeah, blockchains allow us to rethink our relationship to things around us. We see things, physical stuff in the world getting more agency because they can buy things that support them. And we see things becoming part of smart contracts and being able to take actions that happen on blockchains that then affect the world around them. Thanks very much for listening.